Welcome back. In my previous video, I talked about high-level synthesis, and in this video, we will go about implementation on the FPGA board. Previously, I showed you guys how we use the C code to generate the RTL and how to perform design analysis using Cyber Workbench. So today, we are going to take a step further and go about implementing the RTL on our FPGA. So for this design, our main requirements is from the FPGA, we need to take 8-bit input, a push button to register the input, and based on those inputs, evaluate our average, moving average, and output the same on the 7-segment display. So here the top module is AV8_7F, where this function takes in two inputs, the switch value and the key value, where key is just a Boolean value and the switch is a 8-bit value, and performs the average and decodes the signal to be sent to the 7-segment display. So here, first the switch values are read, and based on the key value, we call the average function. For the key press, we only evaluate the rising edge of the key so that the average is not calculated throughout the whole time. Let's say the user is pressing and holding the push button. We just want the average to be calculated when the button is pressed. If the user continues to hold the button, we don't want it to continuously evaluate the average. So for that, we also have a variable called as previous key, where it stores the uh, value of the previous key value. So we want the present key to be 1 and the previous key to be 0. Basically, that means a rising edge of key press. Only then we call the average function, which will retrieve us the average value. Once that is done, we split the value into three places: units, tens, and hundreds, using modulo functions, and then decode that value. So based on each unit, we send it to a decoder. Basically, it's an array which consists of signals. Based on, let's say, if it is 0, we send a signal of 40 hexadecimal. If it is 1, we send 79 hexadecimal value. Similarly, for the other numbers. So all these signals are decoded and concatenated to generate one 21-bit value. But since C code does not handle multiple bit lengths, it only handles a standard bit length, whether it is a single bit, 4 bits, 8 bits, or next is 8. So, but C performs only standard bit handling, whether it is 1 bit, 8 bits, 32 bits. So, for our 21-bit signal, we'll have to go to our next best option, that is 32 bits, which is basically an integer. And this integer value will be our 7-segment display signal. So that is the C code that I've written. Uh, we'll follow the same process that I talked about in the previous video for high-level synthesis. We'll first analyze the C to see if there is any syntactical errors. Once that is done, we'll go about synthesizing the code. So first we'll analyze to see if there is any syntactical errors. Once that is done, we'll go about generating the constraints based on our library files that we have provided. Once that is done, we will provide the synthesis options. Here again, we are keeping all the default options and only concerned about the frequency, that is 20 nanoseconds or 50 megahertz. Once that is done, we go about synthesizing the design to get our RTL code. Here for our RTL code, we can see the switch, key, the signal, our 7-segment signal. Also, we can see clock and reset being implemented automatically. Reset here, what it has automatically generated is basically a circuit reset. Once that signal is sent, it wipes out all the memory of the previous input and makes the average as 0. So once this Verilog code has been generated, we can take this Verilog code into Quarters Prime and perform further steps that are required for FPGA, that is pin allocations. Uh, Once this Verilog code has been generated, we can take it to our Quarters Prime application where we can do further analysis, synthesis of Verilog, pin assignment, and then finally generating the bit stream which can be used for configuration.
So using the RTL code generated by Cyber Workbench using the C code, I've implemented the same RTL, that is Verilog code, onto our FPGA. I've used the Quarters Prime application to generate the bit stream, where I've followed the same steps as previous videos, where for the respective RTL based on its input and output, I've assigned its respective pins. Here I've assigned the first 8 switches as the 8-bit input, the first push button as the key value, and the last switch as the reset button. So let's give the input. I'll first give input as 2, same as my test stimuli. Press the push button, output is 0. Then I provide the input of 5. Press the push button, now 5 is registered. I'll give the next input as 7. The output is 1, similar to my test stimuli. Now once I increase my change my input to 8, the average is gonna increase to 2, and the process continues. Let's say I just give the input as 1 and continue to push the key button. The average will drop down and will latch to 1. And let's say if we want to reset the average, we'll just push the last switch to high. It will reset everything to 0. So this is the implementation of moving average functionality, where I wrote the C code to perform the implementation, and then use the Cyber Workbench to create the RTL code for the respective functionality, and implemented the same thing on DE1-SoC board using Quarters Prime application.